In this video, we are going to discuss variable selection procedures in Rstudio using our cement data. So recall in our cement data, we had 4 predictors and our y, which was our response. In R, there is not a simple way to do forward and backward selection with the p-value. So I created some code to help us do this. Typically, when you're doing model selection forward backwards, you're going to use a criterion called AIC or BIC. And R does have built-in functions to do that, but I want this code to at least relate back to our notes so that you can verify and understand what the procedures of forward backward is doing. Okay? So with that, let's get started. Always make sure you're in the right directory. We're going to load our data. And then this would be the full model. Just kind of putting it there. I'm not going to run this. This right here is going to be our alpha levels, whether we're going to be in or out. The first thing I want to talk about is forward selection. So the idea of forward selection is that we're going to have this model with just the intercept in it. So let's run that. Okay, just has the intercept. Now what this line right here is going to do is it's going to build a model for each of the variables that's not in here, but is in the scope of our cement data. So just recall, if we look at our cement data, we have x1, 2, 3, and 4. It knows not to run a variable y because we have our y right here. So let's run this. And what R is doing is a single term addition. And so it adds x1, x2, x3, x4 by themselves. And you'll notice that these p-values match with our p-values that we saw in our notes. Okay? What I did next was I kind of wrote this code, which does the following. It's going to look, remember we called our variable R, so if I print R, it's producing this. What it's going to look for is the R value in this column that is the smallest. That's what this is doing. So it's going to find the smallest value. Which one of these is the smallest? And is also still lower than our alpha in value. So if I control copy this, it's going to give us an index. Oh, forgot to run this part. Boop. Boom. 5. And it's going to give us an indicator. Now if we go to our row names, I'll show you guys what that means. Row names of R are just our variables. And so when I do this, it's going to tell us, hey, what variable do we need to add? Oop. Run. And it's going to tell us to add x4. So what I do next, and again, this is more manually, is we're going to update our model. So our model now has x4, control run, and we're going to rerun this R, and it's going to run it by adding 1, 2, and 3, given that 4 is already in it. Run this, which is the same. Our variable to add now is x1, and we're going to repeat this one more time, same idea, and we're going to be told to add x2. I know this because of our notes. Now, we're here. If we rerun this model, R, we're really looking at whether we should add x3 in here. We see our p-value is pretty large. This is going to tell us, this little kind of check, if we run it, is going to say character 0, which means we're not going to add anything, and our forward stepwise procedure with our p-value is done, and our recommended model is x4, x1, and x2. Okay? The same idea is going to happen with backwards, but instead of, notice we had add 1, now it's going to be drop 1, because we're going to start with the full model, and now what this is going to do is it's going to look at if we dropped one of these variables from the model and how it's going to impact everything. And so these p-values are the exact same as the p-values in our notes. This right here is a little bit different than our forward because we want to find the p-value that is the highest. So in this case, that's this p-value. And we want to also find the p-value that is greater than our alpha out. So we want the p-value that's the largest and is also greater than our alpha out, and that's the variable we're going to drop. And so this is going to tell us to drop variable 3. We can repeat this, and we're going to drop variable 4. Okay, so we're left with x1, x2. Oop. Paste. We're going to look at our R real quick, and we can notice that these p-values right here are both lower than our alpha out. And so that's pretty much what this is going to tell us. It's going to tell us character equals 0, and so we know we don't need to run anything else. If you combine the above steps, you can get a stepwise for p-value. But in practice, p-values aren't used, and so you want to utilize AIC or BIC. One way to do that is you could use this code right here called step function. And if you have any more questions about step, you can go $step, enter, and it helps you kind of work through that. For you guys, probably a more useful tool is the exhaustive and all possible subset selections. And so what this is going to do is we first need a library called Leaps. Leaps is going to really input or import this function that we're going to use. This function can also be used for other methods. So again, if we have any questions about functions, we can go type in that. I already had libraries loaded, so I didn't have to run it. And it can always tell us more about the different inputs and arguments that we have. So you can notice that you can also use forward, backward, and seq rep, which is the mixed approach. Simply though, you have y tilde. This dot pretty much says use whatever variables are in this data. We're going to use the exhaustive, which is another term for all possible subsets. This NV max, we'll scroll down here, I'll show you where it is the maximum size of subsets to examine. So if I put 4, we're only going to be interested in the top 4 models. So I'm going to make this a little bit bigger and say maybe 15 or 10, whatever we want. N best is the number of subsets to look at for each size. So let's first, I'm going to put this as 1, and then I'll make it 10, and you'll see the big difference. So we're going to output 10. So we're going to run this, and we're going to run output. Output itself is not the prettiest of looking, and it doesn't provide us straight away with our R squared, adjusted R squared, CP, and BICP. So that's what this code right here is doing, is it's getting the values of our R squared, our adjusted R squared, and all that, putting it into a nice table. So control copy, paste. This could be a little bit hard to read because of so many decimal points. So something you can do is just round it, and it won't be that big of a deal. So we're going to round to the 3rd digit and run that here. Right now, these results don't show us what model this relates to. So what we need to do is add this output outmat. And what this is doing is telling us what variables are included. So this right here is just a nice way of looking at the output altogether. Okay, so 1 parentheses 1 has only x4 in the model, with this R squared, this adjusted CP and BICP. Notice that it's only producing four models, but all are the first. Let me change up some parameters and then I'll show you kind of how things differ. So what I'm going to do is right now what it produced was one model with one variable, one model with two variables, one model with three variables, and one model with four variables. If I increase this n best to maybe 3, and I rerun it, boop-a-doop, and we look at this, now it's going to give me the best 3 one-variable models, the best 3 two-variable models, the best 3 three-variables, and there's only one full model. And so that's kind of how that number's playing into. You'll also notice that we only have 10 results. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's where this max n10 comes from. Okay, so as a recap, what these results are showing is the star means that it is in the model, and then you're getting your values. And that's it. Oh, that's not it. I think I already mentioned this, but you can change this exhaustive to forward, backward. It just won't use the p-value. And now that's it.